Recording. Okay. Previously, we already did up to the sampling, and we discussed about sampling distribution. Okay, of a statistic. Okay, sampling distribution of mean. Okay. So then now when we know from here, we learn that it's actually got something to do with chapter 2. Okay, linear combinations uh, of distribution. Okay, from here we like to highlight two conclusion. Okay, we like to highlight two conclusion. Number one, if x is normally distributed with mu and sigma square. Okay, if x is normally distributed with mean mu and sigma square, then bar x, okay, the distribution for sample mean will be also be normal distributed with mean mu with variance sigma square over n. Okay, we need to use this rule when we comes to chapter 5 later. Okay, we need to use this rule when comes to chapter 5 later. Number 2, if, okay, not if, given, okay, distribution of x unknown. We don't know what is the original distribution, but we know its mean, mu, and variance sigma square. Okay, somehow we managed to use the calculation to calculate the mu and the sigma square. Then, okay, bar x here, which is we are taking a lot of samples. Okay, so sum of x over n here will be normally distributed with mu and sigma square over n for n greater equals to 30. That means this actually tells us that if the sample is big enough, okay, regardless whatever the distribution, it will become normal distribution. Okay, it will become normal distribution for the sample mean. This part 2 here is called CLT, central limit theorem. Okay, and when it comes to your S2 and your further stat later, will be strongly rely on CLT. Okay, the question will be strongly rely on CLT. So let's see. Okay, then okay, let's see got any example or not. Okay. Okay, example 9. Okay, example 9. Okay, a packet of cereal are labeled as containing 500 grams of cereal. The actual content can be modeled as a normal distribution with mean 503 gram and standard deviation 7. So the original, okay, use red color. The original, it says that is normally distributed with 503 and 7 square. Okay, what is the probability that the mean containing the random selected 10 package will be 498 gram? So the question is asking about what is the probability of mean, okay, so will be under 498. In order to answer this, we need a second information, which is bar x. the n equals to 10. Because originally this is already normal distribution, therefore it will just follow the first rule. Okay, our first rule. It will just follow our first rule. Then this will be also normal distribution with 503. Okay, 7 square over 10. It will actually work like this. Then from here, we'll do our calculation. Probability of z lesser than 498 minus 503 over square root of 7 square over 10. Okay, then after that, of course, you press inside your calculator. Okay, where is my calculator? Okay, so you will get distribution lower negative 10. Then this is 498 minus 503. Okay, divided by 7 over square root 10. Okay, so you have a P of z lesser than negative 2.258. So you have your value of 0.01195. That's your answer. Okay. So this is what happened to your answer or calculation. So you can see that the first part here, okay, gives you information about the population. Okay, population. Then, but the question is for the sample mean. So during exam, don't make such kind of mistakes. Then, if you didn't divide it by 10, it will be totally the different values. So it is important that you actually understand what the question is actually talking about. Yeah. Okay, let's look for other example. Okay, let's look at the second, the example 10. Okay, let's see. The volume of a liquid dispensed into a bottle is normally distributed with 500 ml and the standard deviation of 6.2. So, volume, okay, normally distributed with 500 and 6.2 squared. A random sample of 5 bottle, okay, n equals to 5. What is the probability that the mean volume of 5 bottle is at least 504? So this one is asking about mean 5 greater than equals to 504 at least. Okay, so in order to answer this, we need to get our distribution done first. Okay, so in order to get this, I need to get my bar x is n 500 with 6.2 square over 5. So over here, I need to write my calculation of 504 minus 500 over 6.2 over square root of 5. Okay, P of z greater equals to, let's see what is the value. This one is 4 divided by 6.2 over square root 5. Okay, so you have a 1.4426, so give you 0.0746. Okay, then for the second question, another random sample to be taken. What is the minimum sample? Also, they didn't tell you the n now. This is a reverse question. Okay, need for that to be no more than 1%, that is mean value greater than 501. So P of bar X, okay, which is greater than 501 is no more than 0. No more than 0.01. Okay, this is totally a reverse question. As you can see, this is a common question during exam. Okay, I have P of Z, okay, 501 minus 500 over, okay, 6.2 over square root n, okay, lesser than 0.01. So over here, okay, I have a P of Z greater than 1 square root n over 6.2 lesser than 0.01. So let's see reverse calculation. In inverse normal 0.01. Okay, we have a square root n over 6.2 is equals to negative 2.326. Okay, so n equals to, okay, so answer times by 6.2 square the number. Okay, I have a 208.033. So this one, let's try some logical thinking. Is the answer to be 208 or 209? Okay, so you can actually check. Okay, so go back to, but our objective is to make sure it's lesser than 0.01. So we can maybe do checking of P of Z, okay, greater than, okay, this is positive value, this greater than, this is positive value, okay, greater than this one, square root of 208 over 6.2. Let's see what is the figure. Okay, normal CD, okay, lower square root of 208 divided by 6.2, upper 10. Okay, I have 0.010049, but if I calculate Pz of square root 209 over 6.2 equals to, let's see, okay, square root 209 divided by 6.2. Okay, I have a 0.00985. So which one is the answer? Okay, a lot of students, maybe when they see 208.033, some students maybe straight away take the answer as 20, but the correct answer is 209. Okay, but the correct answer is 209, that you can actually see from here. Okay, next, let's see other example. Okay, please remember that the reverse question is actually a common question during exam. Okay, so let's see what do we get for the next example. Okay, on a flight there are 43 bag check-in. Okay, use red color. Historical records show that on a row of the mean weight of the checked bag is 12.1 kg with a standard of 3.8. So this one they didn't tell us is normal. Didn't say is normal. So we cannot assume. Okay, but what we have here from the information is only have the mean and the standard deviation. That's all. What is the probability that the mean content of the checked bag on this flight will be under 11? Okay, so the n here is 43. So n equals to 43. So you can see it's already more than 30. So immediately this is by CLT. by CLT. Okay, bar x is 12.1 and 3.8 over square root of 3.8 square over 43. Okay, then calculate the value. Probability of mean is under 11. So P of Z lesser 11 minus 12.1 over 3.8 over square root 43. So the rest you know how to do. It's just a basic calculation here. Okay, so what we have here is negative 10. Okay, bracket 11 minus 12.1. Okay, divided by 3.8. Okay, over square root of 43. Okay, so I have a negative 1.898. So equals to 0 0.0288 as your answer. Okay, so this is CLT. Okay, so chapter 4 is not finished yet, but this is up to where we're going to discuss for today first. Okay, stop recording.